For lesson 1.2, we are going to be able to identify congruent segments when you get finished with this lesson. And you're going to be using segment postulates to identify those congruent segments. So we do have a couple of postulates on our note sheet here. And we do have one vocabulary term. We want to know what a postulate is. It's also called an axiom. This is just a rule of geometry that is accepted without proof. So we just take it for granted that this is going to be true. We know that it's true because it's been used in mathematics, and we're going to just believe that it's true and apply it in the appropriate situations. So go ahead and stop the video, copy down what you see on the screen, and then we're going to go ahead and take a look at both of these postulates individually. For postulate number 1, it's called the ruler postulate. We don't have to memorize that it's the ruler postulate. You just have to be able to understand that, what it says. The points on a line can be matched one-to-one with real numbers. So if you take a look at a ruler, if you can imagine a ruler, and we can say that this is 1 inch, 2 inch, 3 inch, 4 inches. Obviously, it's not to scale. But there's a 1 that associates itself with that particular place on the ruler. And there's a 2 and a 3 and a 4. So it's just saying that the real number that corresponds to a point being, let's say, right here, there's an actual number that corresponds with that, and that would be called the coordinate of the point. So even if we had an XY axis like this, and we were going to plot a point, we should be able to see that there's negative numbers on this axis, there's negative numbers on this axis, and we could actually see that there's a point that has two values, the x value and the y value associated with that. And the distance between 2 points is going to be the absolute value. Well, absolute value, you may remember this from algebra, we have some brackets that look like this, the straight up and down brackets, and if we had 4 minus 6 inside the absolute value symbols, we know that 4 minus 6 is negative 2. However, absolute value cannot be negative. It must be positive. So really it's just a distance. It's a distance from 0. So absolute value must be positive. So instead of saying it's negative 2, we're going to say that this is just 2 because it's 2 units away from 0. And that's really what absolute value is. It's the distance from 0 that the answer is. When 3 points are collinear, you can say that 1 point is between the other 2. Okay, and that makes sense, I think, if you just think about it. If you're looking at a segment like this and we have an A, a B, and a C, B is between A and C. Those are 3 collinear points. Collinear, again, just means that they all lie on the same line. And if you're coming across anything here that, doesn't quite make sense, you're not clear about something, and you're working on some problems and you don't understand something, remember, always write down the questions that you have somewhere on this sheet, and then when you get to class, make sure that you actually ask those questions. That's the benefit of having me in class with you while we're working. So please make yourself available and also get the help that you need. Okay, with postulate number 2, it's the segment addition postulate. So we want to realize that you can add 2 segments together. And remember, a segment is just a portion of a line. A line continues on an infinite distance, but a segment has 2 endpoints, and it consists of all of those points in between the 2 endpoints. So if we were looking at, let's just say the segment that I had drawn, ABC, so this drawing over here to the right kind of goes along with the postulate that we're going to go through now. So it states it 2 different ways. If B is between A and C, then segment AB, this segment here, plus this segment here, BC, is really the sum of the whole thing. AB from here to here plus BC from here to here equals the entire length of AC. Now it says it the other way as well. It says that if AB plus BC equals AC, then that gives away that B is between A and C. Okay, so if you saw it this way, you would have to say, yep, I know that B is somewhere between A and C. All right, let's take a look at the next sentence. It says that line segments have the same length. Line segments that have the same length are called congruent segments. And I do want you to write this symbol down for the word congruent. In geometry, there are many, many symbols. and these are ones that you want to be familiar with. So you'll want to make sure that you know the difference between the equal sign. If you take a look over here in the box, the word equal, and then the word congruent. Congruent just means that it is the exact same length. Okay, so it's talking about the length. Equal means that it's actually got the same value. So this one has a value to it, and this one is just thinking about that it is the same length. Okay, so there's just a slight difference between the equal sign and the congruent sign, but you do need to know the difference between the two of them. And the other difference that you might notice in this statement, this does not have the bar on top of it. Okay, so segment AB equals CD. You do not need the bar on top of the two letters. But in this case, when we're talking about length, we're definitely talking about the segment itself. So we do need the bar when we're talking about that in terms of being the same length, not having the same value, but being the same length. There's just a slight difference. Make sure you ask if you're still unclear about that. Well, we've come to our first example. The first example says to find a length. And in this case, we need to find the length of BC. We don't know the length of BC. That's this portion of this line between B and C. How long is that portion of the line? Well, we first can go back to looking at the segment addition postulate and realize that AB plus BC is going to equal AC. And do we know how long AC is? Well, it says in this indication right here that from A all the way down to C is 32. And we see that AB, this portion of the line, is 10. So if this portion is 10, but we don't know what BC is, let's give it a variable, let's give it x. Really, we just have an algebraic equation here, and we can actually just solve. And we would just subtract 10 from both sides, and that gives us x equals 22. Okay, so in the next three problems, the on your own problems, I would like you to practice and find the length of BC. Make sure you show your work similar to what I did there in the example problem. And then, of course, I have this space right here if you need to ask any questions about this type of problem or anything on this page. Please make sure you do that. Thank you. And when you're answering these questions, it's probably going to be a good idea for you to write BC equals so that I can see where your final answer is for each of these three problems. All right, let's go ahead and turn to the next page. All right, so in example number 2, it asks us to compare segments for congruence. We're going to use the diagram, which we have as a XY coordinate grid here, and two segments have been graphed on the coordinate grid. Use the diagram to determine whether segment AB and segment CD are congruent. And you might remember, just means that they have the exact same length. Okay, that's what we mean by the word congruent. So we're going to be taking a look at the values of x and y. Here's a -1 and a +7. Remember, this is the x value, this is the y value. And for point B, we have an x of 3 and a y of 7. So the 7 is the same for both points, right? That's the y value, that's the same. So in order to find out the length of the horizontal segment, horizontal means that it, runs the same way as the horizon, find the absolute value of the difference of the x coordinates. Okay, so I'm going to look for the x coordinates, that's -1 and 3. Those are the x coordinates of both of those points. And basically I'm going to take the absolute value, so I'm going to subtract -1 minus 3. Remember, the vertical lines, the bars there, are representing the absolute value. An absolute value is a distance. It is never negative. Okay, so it has to be positive. So your value that you're going to get out of this answer will never ever be negative. Well, if we take -1 minus 3, that equals -4. However, we cannot leave it as a negative number, so we're just going to say that the segment AB is 4 in terms of its length. No length is ever negative. If it's actually there, then you can't say that it's a negative value. Okay, the next step is going to be taking a look at the vertical segment, and that's a segment called CD. So how far do we have to travel on this line from C down to D? Well, it looks to me like our x values are the same, so we know that we're on x equals 2. But if we take the difference and basically take the absolute value of 5 and 4, so we're going to draw this out, 5 minus, I'm sorry, 5 and 1, not 5 and 4. 5 minus 1, we get 4, positive 4, and absolute values have to be positive anyways. So it looks like segment AB, which is horizontal, and segment CD, which is vertical, in this example, are both the same. So we can say yes, AB is congruent to CD. And that is how we write it. Remember, this is the symbol for congruent. Remember, this is the notation for writing a symbol. So you can answer that yes. So in the next 3 problems, I need you to do the same kind of work. Show your work at the bottom underneath each one of these graphs here. Are they congruent? And how do you know if they are congruent? And you can show your work. Make sure that you explain. There is some room down here at the bottom of the page in case you want to ask a question about something when you get to class.